Thanks, Andy, and thanks, Jeff, and the BrainXchange team for championing AGCO and also making a crowd of people that make me probably the most nervous I can be when I speak, because you're all so smart in your own areas. So I hope I have something that you can take home with you today. For those that don't know AGCO, we're an agriculture company. We make tractor sprayers, grain bins, precision planting tools, and we're global. So we have 53 plants, and I'm going to play a little bit off of what Andy said and how to scale these solutions. So I wanted to start with this is stupid simple, right? Everyone understands this. Change is inevitable, but innovation is also inevitable. So really, as I go through the presentation today, I'm hoping that you come to the end of it and anyone who's in here saying, but why, really understands the reasons why not, right? I think AGCO's done a really, really great job of concepting, finding value, and implementing at a scaled level some of the solutions that we're going to talk about today and that are being presented out in the lobby. So I always like, too, the Einstein quote of, if you always do what you always did, you'll always get what you always got, right? And I think that's something that we all get sort of stuck in, but the world's moving forward. I struggled a little bit with disruption. I don't know if anyone's ever looked the word up as I sat out there. Disruption, some people say Uber is not disruptive. It actually replaced a niche in the market, but it didn't change the market. When they talk about process, though, they say that when you obsolete an old process and bring in a new process, it's disruption. So most of the things that we're going to talk about today, from the virtual reality, the augmented, 3D printing, the way we do Wi-Fi, the cryptocurrency, all of those things are considered disruptive to process. And then I challenge you, and it's kind of nice the way everyone started, Brian and Michael and Andy. I challenge you to figure out where you are in this game, right? I mean, are you an innovator on the front end of it? Are you planning on being a laggard? I don't know if we've gotten far enough along yet to have laggards. But I think there's a lot of early adopters and a lot of early majority right now. And I find that some of the reasons when I talk to companies that we're slow in that is our corporations don't support us being disruptive and innovative, right? Purchasing team or finance team, all of those rules that we have in place that really supported the way we used to work may not be supporting us as we go forward. So I'm going to talk a little bit through that here too, and some of the things AGCO has done to work around that and bring it in. So when we talk innovators, I brought this up. I haven't used this slide in a long time. But I was having some fun looking at glasses in the world. So in 1286, the first pair of glasses was invented. It took till 1400 to have a nearsighted version, and 1600 to put the arms on. So things were very slow, right? That was disruptive, and yet it was very slow. Nowadays, our infrastructures are there and in place, and they should make it quite easy for us to be innovative in our workplaces. That's not really what's slowing us down. So we started in 2013 with one pair of consumer glass. And now we're in 2019 and we've implemented them, and we'll talk through this in a little bit, but we've implemented them, our electronic work instructions, our quality gate, quality checklists, remote expertise in the field, and picking in our warehouses can all be done now in wearable glass and smart glasses. So I like to bring this back up as I was thinking through my own mind the history of disruption. That seems like a long time, but boy, it went quickly. And working with the vendors to get there was half the fun of doing it. So I think the biggest problem we have when we're not moving forward is making innovation the new normal, right? I listed off here the things that AGCO really addressed, literally. Creating that culture of collaboration and learning, engaging employees, right? So we're 20,000 strong now as an innovative company. All of our employees can put ideas in and work on their ideas. We actually close some of our plants down an hour a week so that they can work on some of these ideas to make their work area better. Engaging the right executives. Not everyone believes in the disruption and the innovation. Reward innovation, but if you look down 3 more, reward failure. And that's a place I think we really struggle. And that's something that we really need to start looking at. And there's programs out there to reward failure, because those failures can usually turn into something that's far exceeded what you had even planned in that first proof of concept initiation. Take ownership of the problem. We're going to say, never be a hammer without a nail, right? I mean, that's just, you're never going to make it. You have to have the problem, and then you go looking for the solution. Benchmark against the best. This one's critical to me. Make sure your goals and your metrics align with innovation, right? So when you tell an employee, I'm going to measure you every day on tap time, you have this much time in the day, this is what you have to do, we're not allowing a lot of ingenuity or creativity in how they approach their job. And then lastly, recognize the importance of innovation outside of the product. So here I have a descriptor, and you can see the customer side, the customer experience, and then the product innovation. Those are both things that are very, very relevant in most companies, including mine. And then that big box in the middle, which is process, the whole supply chain, we're sort of forgetting about that, and eventually it's going to catch up with us because our consumers want more, faster, more complex, exactly the way I want it when I want it, right? I mean, we've taught them that. Amazon does a pretty good job of teaching them that that's the way the consumer world works. They want higher quality. They want longevity, longer working products. So that middle piece is the piece that I am identified with and trying to find out how we can be more innovative to ensure that our customer experience is always the best and that our product is the most innovative it can be. So that being said, we come back to starting small. So we had that discussion again this morning. I feel like I'm only the third speaker, and yet we've already talked these things through. So you can tell it's becoming standard in how we approach these. You know, boiling the ocean, I think, is the thing that shies most companies away from ever starting, right? You don't even know where to start. How do you get electronic work instructions in class when I don't have electronic work instructions, right? So all kinds of questions that come back in, and then it's just easier not to do it. Problem has to meet the user's needs, has requirements, right? Hammer and the nail. Has to drive business value, critical, not just the shiny nickel. And the tools have to exist and the skills in the organization. So we talked a little bit about training in the organization is critical right now, right? Jobs are changing. You know, people are programming their own Cobot work partner now. And in the industry, right? So some tools we're pulling along because we need them faster, right? And the magnitude of people in this room, if we're all pulling those tools along, we're going to get there a lot faster. And then the proof of concept death trap, right? Anyone hit that one yet? Where everything on your floor is proof of concept. You're not really driving value. You have nothing to scale. It was a great idea when you started. Maybe it's a failure, so now it needs to be reevaluated and figure out how you make success out of that. And then this is just a little insight to how we look at what is driving value to the organization. So I have a little bit different, some of the people sitting up here, a little bit different organization. My global digital transformation, that's pretty much, we have 3 people on the team. We believe that our plants and our people have the ideas and the aptitude and the ability to drive the value, collaborate with the other plants, and scale that value. So we're taking full advantage of all of our employees to get that message across. We have a digital playbook, so if it's a small plant, they don't know how to get in the game, you know, really tells them the innovation projects we're currently working on, why would I get into one, how do I decide if there's value, where do I go to find a vendor, how do I know what it's going to cost. Every single project we have has an IT person, a purchasing person, and a finance person on that team. Right, you don't want to come to the end of it with your big idea and have that roadblock come up there. So we have them in from the front end. We bring every plant, or all of our key plants, come in once a year, and they rate for what they believe the innovation value would be driven and the cost of implementing it. And we throw all those around in bubbles and spiders, and we come back with about 10 to 12 solutions that we believe AGCO can gain great value from. And then we assign a center of excellence. So if we have a solution and it's an AGV and it's being worked on in Germany, Germany will be our center of excellence. And they'll pull together a call every week for all of our global people. And they'll start sharing information and requirements. And you may have 2 or 3 proofs of concepts, but at least they're all being held under one umbrella so that we know that we're fighting towards the same cause. The other piece of it is, and this one's sort of tough, and that's where it comes back to boiling the ocean. You need that foundation, right? You can't just build on top of quicksand. So we're not done. We're still working on the right footprint for our ERP, our PLM, and our MES systems. How do we lean them down? How do we make them so agile that when an innovation comes along, we can plug it in quickly and be working from it and find out the value? It's not a 9-month project or an 18-month project because our MES layer is big and our ERP system has bad data. Right, so we're always continuously cleaning that too to make sure it's supporting where we're going. And then the last piece, right, so we said think big, start small, fail fast. So, and do it quickly, right? And do it recognizably. That did not work, now we're going here. It's not something that we should have to bury. So, we believe in learning from the failure. I was looking up some people who have failed and succeeded. Colonel Sanders, 1,000 times didn't get to sell his chicken recipe. I told my table I think he should have sold the biscuit recipe first and maybe the chicken one followed. But, 52 attempts for Angry Birds. Steve Jobs, right, went down and came back up again. Walt Disney was told he wasn't creative enough. So, I think someone said one day, if you asked Uber to talk to the taxi drivers to figure out what they were going to do, would it really have been a disruptive peer-to-peer type solution? Probably not, right? So here I'm going to talk about, this is the team I spoke to, and there's more than this, but these are critical people. So they don't report to me, they just believe in this cause as much as I do and my leadership does. And so they own the COEs right now. And so today I'm going to switch it up a little bit for you guys. You're probably sick of hearing me talking. It's been 3 years in a row. And I'm going to bring a couple of them up so that you can actually hear and see the solutions they're putting in their plans. So I'm going to start with Rick Ryder, and he's going to come up and actually deliver on the wearable piece, exoskeleton, smartwatch, smart glass, and then the kinetics sensors.
Good morning. So I'm just going to basically go through the Global Center of Excellence project that I lead in wearables. All right, so the approach that I've taken with this team is one, always start as a lean kind of approach. It's kind of my background, continuous improvement. And I really like the idea of you need to solve a problem that became very evident along that glass journey. We had lots of problems through that process, and on all the other Center of Excellence projects we're doing, we're following this as well, specifically wearable. So have a problem, find the cause of that problem, implement a solution. Not, hey, I found some new tool, and my solutions I can better implement it because people tell me to implement it. That doesn't work, and we actually have a use case on that one, so I think that's going to be my first one here. So this was our backwards approach. What happened was some executives went around the globe, told everyone they saw these exoskeletons, all the sites need them, and so we were having our global call every week. When we got to the exoskeletons, we kept hearing about more and more sites buying these exoskeletons and trying them out. And they all seemed to kind of come to the same conclusion of people just not adopting them well. Not saying that the exoskeleton doesn't work, but it was our approach. The executive came by, said, hey, you need to buy one of these. It was like a blank checkbook. They bought them, and they put them where they thought they would fit, or we now have a hammer, and everyone starts searching for a nail. So, as you can see, there's several people in the paint process, working overhead, and doing assembly work. What we noticed was it wasn't 100% of the time that they were needing the exoskeleton. So the negative impact of having something on you and kind of having to work in some tight environments was kind of the negative. And this is a very intimate product. You're putting this thing on a person. It takes a little time to get in and out of, and you're wearing it. So they really want to have that immediate value, and the person on the shop floor just didn't see that immediate value all the time. So we decided to kind of just scale back some of these proof of concepts. for the exoskeleton, and now we kind of are resonating with two of them, one in Germany and one in South America. So not dead, but we're definitely going to make sure we have the correct approach. All right. Another one, wearables. Very simple use case here. We had one of our sites, very large site, a lot larger than this room or building area. And really they walked through a problem. Now this kind of goes down to our culture here. They came up with a really neat cause. The tugger driver was unaware when to deliver parts. Not having the lean culture, probably the team would have came to something, hey, we don't have enough people delivering parts. But since it's a cross-functional team, they involved everybody in logistics and assembly because the assembler doesn't have the parts when they need it on the big giant assembly line. And they realized that the tugger drivers drive around empty a lot, looking for where they need to deliver the carts next to, and then going to pick up those carts and then kind of running around delivering them. And really the tugger driver's like, hey, look, I don't like driving around with nothing on my carts. I just want to know when the assembly line indexes. Seemed simple. We got them I think we got them an iPhone, paired it up with an email system or our MES system and got some notifications on a screen. That worked out great until they set the phone down and it falls off the tugger, or they lose it, or they drop it and they run it over because those things happen. And then the new problem comes, well, I keep breaking this thing. How do I not break this thing? And then that solution became really simple. So we just got an Apple Watch, paired the two together. The guy or gal wears the watch, the phone stays on a holder, everybody's happy. And in the video, it's kind of small. You can see he actually looks at his watch to get the next notification where he needs to go next. Now it's very simple. He just kind of keeps a log of where he needs to go next. And it solved the problem. Another simple use case or another simple problem that we had is we have an on-site occupational therapist at one of our plants, or all of them. And they were seeing that people that are in our logistics or kitting area have a lot of lower back strains. So the cause on there is the training wasn't effective. So the first solution, I'll go into that one and this one, was the occupational therapist went out to that work area and provided training, and provided more training, did direct observation, did some coaching, provided more training. And that took a long time. And there was a benefit to that we start seeing the lower back strains kind of go away from that area, and then it started creeping back. And we're like, okay, what's going on? Why are we going to do it? I think it's one of these shows here where we saw this kinetic device. We thought we'd give it a try. It's like a pager size device you wear on your hip. And what it does is it gives the person immediate feedback. It vibrates when they do an incorrect posture bend, and specifically for the lower back. So what they did is they wore it for several months, I believe, or several weeks, and it provided the worker the vibration right when they did it. So they now can say, okay, however I just did this lift, I'm doing it improperly, so I need to change. And the result was 30% reduction in the number of high-risk movements in the day of that group. So they literally wore this device about a week without any feedback, just so we could collect the data. And then we turned the feedback on for the next 4 weeks. And that's where we got the number 30% improvement. Now, that's not 100% improvement, that's just 30%. And so what we did then is we said, okay, well now we know what you're picking, we know when you're picking these parts, we know when you're doing these incorrect posture bends, we can overlay the data and try to figure out what attributes of these products that are left are causing you to do these incorrect bends. And as we're aggregating this data, we start realizing that our problem-solving culture kicks in, and literally, the people doing the work kitting, they're filling in these tickets time after time, saying, hey, this part needs to be moved from here to here, it's awkward. So we mined the data and got to a very similar conclusion that somebody on the shop floor can do with a suggestion or a request to our materials and logistics department on moving those parts around. Now we built a database of product attributes with this, so we kind of know now how to slot our warehouse more effectively. So we kind of took it and learned from it, so hopefully we can prevent this from occurring again. All right, last one I'll get into, problem, and I think this is the one we'll get into. Employees are taking longer than expected to complete their work, or at a higher rate of defects. So it's really hard to see on here, and I'll show you. That's a pretty big work area. These tractors that Peggy showed up on the screen aren't little, and this is the workstation of doing one of these tractors. So these green lines represent all the material movement, just grabbing it apart, installing it, grabbing it apart, installing it. That works great. But what we didn't really ever map was how much time they go to seek information. What do I assemble? Where do I get this information from? Well, today, or in the past, it was computers. So I have to walk to and from a computer to see which part, which tool, where does it go, what sequence do I do this build in, all this stuff, and I have to check in that I did it. So these are the tractors, big, awkward things, mixed model, low volume, so that I'm not producing hundreds of these a day. So the idea of having tribal knowledge is really difficult. Sprayers, different assembly line, same thing at that facility in Jackson, Minnesota. High complexity, low takt time, or high takt time, low daily rates. A lot of options. So we had to figure out how we get these people this information, right? They're the two people in this workstation highlighted in red, and we have to figure out, well, how do I provide them information? We had to pick a solution, so we thought about hanging TVs in the work cell. Okay, these things are big. I eventually have a sports bar of TVs around this workstation, and I still have to interact with the TVs. We thought, hey, let's get tablets. That worked until you broke them. So hey, mount the tablets on a little stand, drag it around like an IV bag with you everywhere you go. and so that doesn't work. Printed instructions, that was a thing of the past anyway. I threw it up there as an explosive joke. Outdated immediately. And that's kind of where we get into the wearable device. So our result is people wearing glass, getting their work instructions 8 hours a day, kind of up in the upper right corner is what he sees. The lower video is kind of the time lapse. So the lower video, Wade Todd, he's kind of going through the build, and that's kind of the first time he did that model. He's an expert assembler, he's been here a long time. He will finish 25% faster because he has glass on, because he doesn't really know what he's installing or what he's building. He knows he's an expert, he's built something like it before, so he knows where his tools are, he's familiar with the work area, all that stuff. So he gets very efficient at what he does. It's just that he doesn't know exactly the steps to follow. Now, if that person was brand new, obviously the product is new to them and the work area is new to them, it's about 50% faster. So they really get that information right where they need it. Their trips to that computer got eliminated a lot when they're new hired. Writing down part numbers on Post-it notes and walking around and finding the nuts, the bolts, the washers, all that stuff to do these installs. So, few of the wearable use cases.
So I'm actually going to bring next to the stage Andreas Frank. He flew in from Germany. They have a lot of our proof of concepts. They're doing a lot of the wearables, but we're going to focus a little bit on some of the human-centric solutions that they're putting in place. Some are already in execution, and a couple of proof of concepts. So Andreas.
Thank you very much. Welcome to EWTS. I'm very glad to have one part of the presentation here. I'm responsible for the 7 German plants in terms of smart factory. We're leading 6 of the COEs we have globally. And what we did in terms of logistics was looking at a value stream and trying to improve the whole value stream, where you have different kind of problems. One is the constant flow, one is the traceability and the transparency. So AGVs is a key element. We all know them from the day they're available since around 20, 30 years. But what we were looking at is cutting edge technology. So this means what you see here is a picking scenario. So both of the AGVs were sent to the same place to pick a caster. And what you see here is the swarm technology they have. So one is waiting for the other to get the caster and goes away, and then the next can come in and pick their one up. So these solutions are really helping for a constant material flow. They improve it and they reduce the interaction with the people we have there. So in these areas you have a high fluctuation of people driving forklifts. So this helps a little bit in that area as well. Secondly, same technology. We are running in the production area. It's a 3-shift operation. The company is MIR. They can navigate also very freely, they can go around obstacles. So it's really one of the latest technologies we're having there. And they're very scalable. So one thing we figured out is that this kind of solutions which pull, they have better cost to load ratio. So this helps in the implementation phase of just calculating it, right? But the more beautiful thing behind is that you need a system to run all these AGVs, right? So we talked to standardization committees and other people, and what we found out, we need one layer which is doing the communication and task management, and there's an association which is right now standardizing the communication between this task management level and AGVs. So the beauty of this is you can easily change your supplier with another AGV supplier, because we figured out you have different use cases and you maybe have different suppliers in different countries. So we are a global corporation. This means the suppliers you see here might not be available in all the places we have around the world. And therefore we needed a bit of different solution which is more standardized in terms of communication, so you can flip over easily. Second topic you have in logistics is always finding new parts, right? One part is the AGV, so if the AGVs knows what they're transporting, you know where the stuff is. Second topic is, in some areas this is not beneficial or not possible, and therefore we were looking at a localization solution. I hope the video is running, yes. The right side where we implemented this is production area. It's a very critical environment. You have big machines, you have electric emitting. I'm not sure this word is right, but it's a very harsh environment for a tracking solution because we have a lot of signals going around. And the solution is capable of tracking up to 30 centimeters, which is way enough for tracking casters. So this is just one example where you see one of the casters we put a track on where it's going within the factory within 1 day. So it's moving quite a lot. You can make that quite transparent. You can also generate heat maps with that systems that you see, okay, the part is laying in a certain position for quite a long time, and then improve that process later. So it gives a lot of traceability of your processes you have within your factory. And it's also a very open solution. So we're not just looking at one technology, we were evaluating like 5-6 different technologies. There's ultra wideband, there's Zigbee, there's LoRa, there's wireless, there's Bluetooth. And then we found out for different use cases you might need different technologies. So the software platform we are creating there is quite open, so you can integrate whatever technology you would like to quite easily. The use case you have here is outer area. So with the technology we selected for, let's say, indoor and close to the factory areas, there's a Bluetooth solution. With 6 access points you can cover an area of 4,000 square meters. Which is quite good with an accuracy of 1 to 2 meters, which is enough for the parking area. In addition, what we found out, you can use that stuff for a few other use cases. Due to the time, I just passed over, but I think you can get that one in the deck and have a look up later. Additive manufacturing is a bit different area, but it's also quite important for us. We were thinking about, okay, how can we start an approach for additive? And we are looking at different vendors, we were looking at different solutions. In addition, we were looking at different providers for this kind of stuff. And we found out, okay, to leverage a printer, we need to have some volume going on. And serial parts are quite difficult at the beginning because you have these iterations, new models coming, so on. So you need to talk to quality and engineering. And then we thought, okay, first place could be jigs and fixtures. This is where we started. This you see, and a little bit over-engineered fixture you have there right now, but it's much lighter. It's much cheaper, like 50% cheaper than original one, and the operators are really glad that they can have this kind of easy support features. Last point in my presentation is vision systems. I think it's well known to most of the people who are working in machine business, but the technology changed a lot during the last years. There's open source software available to program them by yourself from Google, from Amazon and other companies. And integration, let's say, how fast you can adapt the solution to your process has become much faster. So with a student, within 2 weeks, with the new sensor systems which are available, you can do feature tracking quite easily, you can compare colors, or you can do even an assembly comparison if all the parts were set up in the solution you have, or in the mechanical group you have to check at the end of the day. So main takeaways for me is you really need to know the different technologies in the market, you need to evaluate them, you need to know your processes you have in place, and then you need to make evaluation and select the right solutions for your processes and your problems. And once you did that, I think you have a good start with your solution, and you can scale that solution quite fast. So thank you very much. And
thank you, Andres. And we have 20 seconds left. Hopefully you'll give us a couple extra minutes. So we're going to bring back home again the wearables. I have Gary D'Souza here from our South American plants, and they're doing a lot of work with virtualization and also just got some great awards with our prosthetics and glass solutions. So here.
Thank you, Peggy. Good morning, everybody. So I've been in Brazil for the last few years working with our manufacturing technologies and trying to highlight projects and opportunities to digitalize the process. First one I'm going to talk about here is what we've been doing with plant simulation. This is where we decided to couple, the space I'm going to be talking about is the convergence of the physical and the digital world. The picture you see up there is actually of a cloud point scan that we did with the factory. And the use case was that, we've got 2 different assembly lines in the same building that we want to combine into one because of strategic decisions in the area. And we've had just a few months to come up with a model of the current state, a simulation of the current state, and then proposals for future states and what they needed to look like. And there's nowhere we're going to go in and model all of that in 3D space, so we looked at cloud point scans. We were able to take one on the factory in just a couple of weeks, with maybe a little bit more for processing time, and then use that in the simulations that we built with Technomatics. What you're looking at here is a 2D view of the simulation, where you have to build the logic behind the processes. Every single object and element that you see moving in there is something we had to set up. We partnered with a local institute to do this. We were fortunate enough that they had the expertise at the time to help us out with it. But we built a solution in here that we're able to take different parameters for the scenarios, like what model mix are you running, what type of resource load do you have, what are your feeds and speeds in each area, and scale that out to different solutions. So what you're seeing here is the whole assembly line. We've since done projects on different work centers, individual machining centers, things like that. And we've also been able to take on projects from other sites as well, with Peggy's leadership here, by driving the collaboration between factories. And what you're seeing here is the convergence of that cloud point scan that we did, plus the Technomatics tool where we did the plant simulation. There was some processing in there to make sure we scaled it down to exactly what we needed to see for the simulation, so we have things like posts, electrical connections, critical things for the layout that are all in there, and then the rest of it comes from the 3D model. The next one I want to talk about is Cobots. That's collaborative robots. The use case that we have here is for applying sealant and adhesives to different parts of the motor. I'll just go on to the video here. The real disruption in what we're doing here is that this is a robot that can collaborate with the worker in the same cell. They're able to grab the arm and program it. The parameters that we've used in there allow for this tool to apply just what's required, and you see a lot less wastage of sealant or glue. And this addresses a lot of different quality issues. It addresses change as well, because the worker is able to change that programming on the fly in the workstation. And we were able to work with a third-party provider there to help with that. Last slide here I'm going to go through is on the wearables program. So kudos to the team that Peggy worked with from North America in Jackson and with Google and Prosthetics, because the solution they built was so easily scalable. When I do training now, I have to do maybe a half hour with the engineers, and maybe less than that with somebody that's using it for the first time. And they're able to go off and author these complex processes and checklists and get feedback and really see the value, very, very quickly on the shop floor. What I'm showing you here is the use of Google Glass and Prosthetics in the TPM environment, where a worker is able to access the list of what he has to be able to do Much like what Rick showed you earlier with the assembly instructions, he's looking at things in the top left of his field of view. He's able to go through the different steps, record data, take pictures, and towards the end of the video here, I don't know if I'll be able to get through it, but he's able to also call team leaders or the next line, in his help chain to come and resolve a problem or look at a defect that he's found. The use of this sort of technology has got a lot of publicity for us in South America. What you see here is a regional award where the guys that worked on that TPM project received a lot of kudos from the Association for Quality in Rio Grande do Sul. That's the state where we had this plant. Since we, speaking of scalability, we first started with Cobots at the very bottom there, and we're able to scale it up very quickly to the other factories that we have in Brazil. Again, like I talked about, the power of how the tool was designed, and designed with scalability in mind, and the easy use of the hardware along with the software is what really kind of brought this on. And last one I have here, just another examples of what we're doing with wearables. This is a sort of a Fitbit to try and track worker movement inside of the facility, inside the workstation actually. You saw the spaghetti chart that Rick had up earlier where he was looking at how much time a worker spent in and out of the station. We're trying to do that automatically here instead of having somebody look at it. And this is still sort of ongoing, but I wanted to highlight one of the potential challenges here as we get further into wearables and sharing of data is that we run into problems with workers' councils and unions about how are you using that data. And the biggest concern there is that we're not using that data to time people, we're actually just using it to gather things like where's the non-value and value added. And that's it for me.
If you have them later, I'm sure. I just want to, again, why not? I mean, look at this table of people and what they're accomplishing within our organization. It's spectacular, and they're still doing their old jobs. So all those big thinkers are the ones that really can move this game ahead. So thank you for your time.